Hello everyone, and let's go ahead and get started today with page 2, our notes on dilations, which also represents the only non-rigid motion that we're going to talk about this year. So a dilation is when we take a figure, a geometric figure, and we do one of two things with it. We either enlarge it, so the enlargement, or if we shrink it, the reduction. So if something gets bigger or if it gets smaller, we refer to it as a dilation. Think about your eyeball. If you walk into a room that has lots of light, your eyeball is going to dilate, meaning it gets smaller so that less light gets in. Whereas if you walk into a dark room, your eye gets bigger, also called a dilation, where it gets bigger so that more light can get in so you can see in dark places. So think about it like that. It doesn't necessarily mean bigger or smaller. It means both, bigger or smaller. Either one is considered a dilation. So what we see here is it says the blank represents how much a figure will enlarge or reduce in size. So when we're looking at a dilation, we have something called the scale factor. And the scale factor determines if a figure is going to get bigger or if a figure is going to get smaller, and by what multiplier that's going to happen. Is it going to get twice as big? Is it going to become a third of the size it was? And we represent the scale factor, I'm going to write that word again, with the variable k. So k is our variable. And one of two things is going to happen. If k is larger than 1, the figure enlarges. So if the scale factor is a number bigger than 1, you're going to see an enlargement. But if the scale factor k is between 0 and 1, so it can't be less than 0 because it can't be negative. It has to be a number that's between 0 and 1. It'll never go negative. But if it's something like 1/2 or 0.83, something like that, we know it's going to reduce or shrink. So a fraction less than 1 is a shrink, where a number bigger than 1 is a enlargement. If something is equal to 1, it doesn't change. 1 means it stays the same. So we're never going to have situations where the scale factor is exactly 1. So you can see for objective 1, it goes and asks us to go through this and state whether the following scale factors represent enlargements or reductions. And all we're doing is basing it off of if it's bigger than 1 or smaller than 1. So look at this first one. Is 1/4 bigger than 1 or smaller than 1? Well, we know it's bigger than 1, so this, sorry, I just said bigger. It's smaller than 1, so this represents a reduction. B is 1.45. 1.45 is bigger than 1, so this represents an enlargement. The next one, 0.17, is smaller than 1 because it's 0.17, so it's a reduction. The next one, 23/15. If you're not sure, you could put that in a calculator. 23 divided by 15 would give you 1 point something, but the number on top is bigger than the number on the bottom. If the numerator is bigger, you know that represents an enlargement. E, the number on top is smaller, 5/6, representing the decimal like 0.833, I think. So that's also a reduction because it's less than 1. And that last one, 11/8, it's another one where the number on top is bigger, so another enlargement. So you can see this one ended up alternating and reduce, enlarge, reduce, enlarge, reduce, enlarge. Again, though, all you're worried about is if the number is less than 1 or the numerator is smaller than the denominator, it's a reduction. If the number is bigger than 1 or if the numerator is bigger than the denominator, it's going to represent an enlargement. So objective 2 says, use the set of points and the pre-image and the scale factor to determine the points of image after it has been dilated. So part A says we have triangle RST that has the vertices -5, 6, -3, 9, and 2, -1. And they want us to use the scale factor 2/3. So what we know is that scale factor is going to represent a reduction because it's smaller than 1. All you have to do with scale factors, if you have coordinates and you want to apply the dilation to them, all you have to do is multiply. That's it. Take all the numbers and multiply them by 2/3. So with fractions, that can be a little bit tricky, but what I want you to think about is you're always going to multiply with the number on top and then divide with the number on the bottom. That's it. Multiply by 2, divide by 3. So to get all of my answers here, I'm going to take every number and multiply by 2, then divide by 3. And whatever I get is going to be all my solutions. So looking at this first one, if I take 5 and multiply it by 2, I get -10. -10 divided by 3, that doesn't divide, so I'm going to leave it as -10/3. 6 multiplied by 2. So 6 multiplied by 2 is 12. 12 divided by 3 is going to give us 4, so that simplifies to that. That's my R prime. S prime. -3 multiplied by 2 is -6. -6 divided by 3 is -2. For the 9, 9 multiplied by 2 is 18. 18 divided by 3 is 6. And for T prime, 2 multiplied by 2 is 4. 4 divided by 3 is 4/3. I can't divide it, so I'll leave it as a fraction. And last, that -1. -1 times 2 is -2. -2 divided by 3 is -2/3. So those are my 3 solutions I'm going to end up with for that problem. Taking a look at B, same idea. This one, though, definitely is going to be an enlargement. That number is bigger than 1, so we expect that our figure is going to get bigger here. And working our way through that, again, we know we're going to multiply by the number on top, so multiply by 5, and then we're going to divide by the number on the bottom, so I'm going to divide by 2. Again, we're multiplying by the 5, dividing by the 2. So I'm going to work through that and see what answers I get. So for A, -8 multiplied by 5 is -40, and -40 divided by 2 is -20. With that said, you don't always have to do multiply first and then divide. You could divide first. So if it's easier to divide first, you can do that. For example, look at the next one, -6. I know that dividing -6 by 2 is way easier. -6 divided by 2 is -3. Then multiply -3 by 5 is -15. And that's the same answer as if you were to multiply first. -6 multiplied by 5 is -30. -30 divided by 2 is -15. So you can do it in either order. Whatever order is easiest, it is okay. All right, for B prime, I forgot to put the prime on A. There we go. 3 multiplied by 5 is 15, and 15 divided by 2 is just going to say 15/2. The next one, 10. I'm going to do it backwards. 10 divided by 2 is 5. 5 times 5 is 25. And C prime, -2 times 5 is -10. -10 divided by 2 is -5. And 4 times 5 is 20. 20 divided by 2 is 10. All right, I'm going to go ahead and leave those last two for you to try applying those same exact rules there. Multiply by the top number, divide by the bottom number, and you'll get those answers. Go ahead and pause it now if you need to. I'm going to go down now, though, and look at Objective 3. Objective 3 says, determine whether the figure from figure A to B was an enlargement or a reduction, and then find the scale factor from the image. So it starts as A, and it becomes B. So in this case, this one started as this triangle here, A. And after dilating it, it became triangle B. So it definitely got smaller. So I know this represents a reduction. And it asks us to figure out what the scale factor is. To determine the scale factor, what we always do, the formula for finding the scale factor is always the same thing. You put the old divided by the new. Old over, nope, that's backwards. That's incorrect, I'm sorry. It's new divided by old. So you put whatever the new shape is or the final shape on top and the old shape on the bottom. What I mean by that is we need to count. So for example, looking over here, the new shape is the yellow triangle. You can count any of the sides, but obviously you want to count a side that's flat, either like a flat one like this or in like B like this. A flat line that is either totally horizontal or totally vertical. So in this case, I can see that this is 2 units long right here. So I know that this represents 2 units. Here I can see that this is 1, 2, 3, 4, 5, 6 units here. So this is 6 units long. So if I'm going to set this up, I'm going to put the new on top. So the new was 2 units long. The old was 6 units long. And I have to ask myself, what number would divide into 2 and 6? So I could simplify this, and they would both divide by 2. So I'm going to divide the top and the bottom by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. And so what I know, actually let me not do it that way. The reduction is a scale factor of 1/3. And I know that's a correct answer because reductions have to be less than 1. And 1/3 is less than 1. So if you accidentally did it backwards, you get 3/1, and 3 is bigger than 1, but you know it's not an enlargement, so you can fix your answer from that. All right, taking a look at part B here. Again, the original was A, so my original, that's not the highlighter. The original is A, so I'm going to do that in blue again. And then the new is B, so I'll do that in yellow again. So in this case, it definitely looks like the shape got bigger. It enlarged. A to B was an enlargement. But we still need to figure out what K is. We know K needs to be something bigger than 1. Use that same formula. New over old. And we need to find a side that we can count. I think the easiest one here would be the one going up and down. So we've got A is 1, 2 units up. B is 1, 2, 3, 4, 5 units up. And since I know the new one is B where it ends, we put that on top, 5/2. That's not going to simplify at all. There isn't a number that divides 5 and 2. So we're going to just leave it as an enlargement with a scale factor of 5/2. And that would be it. All right, just like last time, I'm going to leave those last 2 for you to go ahead and try and see if you can find out the correct answers for it. As always, if you have any questions, please come ask for help, and we are happy to help you.